Suvat equations are really important if you are stood on the edge of a cliff and about to throw a ball into the water. Imagine you threw your little ball in. How long would it take to reach the water? What speed would it be travelling at when it hit it? Or if you threw it up first, at what point does it come past you? How long after you've thrown it will it come past you? And then how long does it take to hit the water? What speed is it travelling at that point? All very useful questions, I'm sure you can imagine. Or you're driving along and the vehicle in front of you brakes. Are you at a safe travelling distance? Do you have enough time to stop? These perhaps are more important questions we can ask ourselves, and you might not necessarily do that calculation in your head while putting your foot on the brake, but the idea, that the maths behind them, is Suvat equations. Given how important they are, we should probably tell you about them a little bit. In your exam, you're expected to derive the Suvat equations, or know the derivation, so know how they come about. And they come about using our old friend, a VT graph. So this axis here, the old y-axis, is velocity. And the x-axis is time, VT, velocity time. So this straight line here models a particle, could be anything, could be a ball, could be a car, could just be a generic particle, as it moves along with respect to time. So let's look at the gradient of this line. Well, we know that a gradient, you should know from GCSE, is the change in y over the change in x. So it's the change in velocity over time. So if this point here is, say, u, and this point here is v, and u and v are u is used as the starting velocity, and v is used as the finishing velocity for any given period of time, then we would do change in y, so v minus u, over change in time, which would be, let's call this a generic t at this point, because we're trying to keep this as general as possible, t minus, and we go all the way back to 0, so 0. Now we also know that change in velocity over time is acceleration. So this gives me that the acceleration is v minus u over t, and rearranging this very quickly, v minus u, so v is u plus at, and there is our first Suvat equation. Another Suvat equation can be found by thinking about the area underneath this line, which corresponds to the displacement, which is the vector distance. So displacement we notate using s, and this is a little trapezium. So we know that a trapezium is found by doing half times the a plus b, the two parallel lines, the length of them added together. So this line here is from 0 to u, and this line on the other side of the, what are we doing? We're doing a graph. This side of the graph is v. So we've got u plus v over 2, and then we times it by the distance in between them. Well, this is our generic distance, t. And this is our second Suvat equation. There are 3 more Suvat equations, and we make them simply by rearranging the 2 that we've just found. So to find this first one, I'm going to, notice I've labelled my 2 equations that I've got at the moment, 1 and 2. So I'm going to take the first equation, I'm going to, oh hello, this is exciting, isn't it? Let's undo that. I'm going to rearrange it so that it's t equals, and then I'm going to substitute it into the other equation. So rearranging this so it says t equals would give me v minus u over a. In which case, substituting it into the other equation where I see t, I get s is u plus v over 2 times by t, which I now know is v minus u over a. This gives me, on the bottom of this fraction, 2a, and on the top I get uv v squared minus u squared, and my uv's cancel out. So I've got uv plus v squared minus u squared minus uv, and they cancel out. If you don't believe me, expand those brackets out and just check, but I'm running out of space here. Rearranging, I get 2as is v squared minus u squared, and so last step, move that u squared over, I get u squared plus 2as, which is super fun. For this second one, I haven't got any v's in it, and this is kind of the thing about the suvat equations. Each one of them is missing one of the letters. So that means that I want to replace the v's in both of these equations. Now 1 is already written as v equals, so let's substitute that into 2. So s is equal to u plus v, which is u plus at. That's all over 2, and it's times by t. So that gives me, expanding this out, 2u, in fact I'm not really, I'm just simplifying, aren't I? 2u plus at over 2 times by t, and now I'll expand out. So 2u over 2 is just u times by t, which is ut, and then at over 2 times by t is a half at squared. I'll leave this one for you to do. See if you can figure out which letter is missing. Use these two to rearrange it so that one of those equations says that letter equals, substitute it in, see if you can reach this formula. There is a suvat song which is brilliant for helping you remember the suvat equations. It basically, if you write out the suvat equations as the song is singing them, by the end of listening to that song several times, not only is it stuck in your head, but you actually know the suvat equations. And it's kind of really useful if you've got those in your brain. So I would definitely recommend listening to that a few times, downloading it, putting it somewhere in the car, whatever. Annoying everyone else that you know, but it's really useful. And then when you're approaching a question, one of the beauties of it is you can just write out suvat. Fill in the information that you have or that you want to know, and then you select an equation from that. Now, this is why it's important that they're right at the top of your brain, because if you know what you've got, you can instantly jump to the equation, and you're not having to then spend brain power trying to find the equation, either in the formula book or in your mind. So imagine I know the displacement, I know the initial velocity, I know the final velocity, and I want the acceleration. I'm going to use one of my suvat equations, and I'm not going to use some of the others. I'm going to use the one that contains SU, V, and A. So I'm going to use V squared is U squared plus 2AS. It's the only one without a T. And then it saves me having to do any rearranging at that point. So we'll do a couple of key examples in class, obviously. The suvat song should be somewhere near this video on the website. And if I don't hear you sort of humming it as you're coming in, I'm going to know you haven't watched it. So there you go. Enjoy.